Hello students. In last lecture we have discussed I/O interfacing and interrupt driven I/O. And now in this lecture we have to study data transfer techniques. That is of two types: program controlled data transfer and interrupt controlled data transfer, which is similar to the topic we have discussed in last lecture, interrupt driven I/O. Basically, both the topics are discussed in that lecture in brief, but now we have to discuss that in detail. So first is program controlled data transfer. Program control means when the data transfer is through program controlling. That means our processor or CPU has to be involved totally in data transfer activities. Means when the data is transferred between devices or computer, all the data must pass through CPU. In this, program in a memory requests the device for transfer data to or from the CPU. Means either data is to be transferred to an input device or output device, but it has to be passed through CPU. In this, CPU and other registers are also involved in the transfer of data. This is the flowchart for program controlled data transfer. In this, while executing a program, CPU is involved in an instruction relating to I/O. CPU executes these instructions by issue a command to the I/O module, and then I/O module performs the request or their acknowledgement, which shows the I/O status. So in this method, I/O unit indicates whether it is ready for the data transfer or not. It will keep CPU busy all the time, whether there is a need of CPU or not. That means whether data is to be transferred or not, I/O devices are to be ready or not for data transfer, but CPU has to be involved. Okay, so due to which CPU involved in these activities all the time, that means it can't do any other work. So the processing is very slow and this only small amount of data is transferred. This is the flow chart related to program controlled data transfer. I/O instructions are used, and in this CPU interprets and sends I/O command to interface unit. Then interface unit tells if you're ready to transfer or not, and if ready, then assembles the word in IBR. IBR is instruction buffer register. Then it is to be checked whether IBR register is full or not. Means if the bits stored in that register, capacity of that register is full, then no more data can be stored in that. If it is full, then the word from that register is transferred to the memory with the help of CPU. Means I/O instructions, when we are using I/O devices, I/O instructions, then CPU interprets and give commands to interface unit, and after that interface unit assembles these words in this register, and then CPU will be free to service them if this IBR register is full. because CPU has to transfer the data from IBR to memory. And if IBR is not full, then the interfacing unit will assemble its data in this. Means CPU have to be involved in this whether there is a requirement or not. And lot of time of the processor is waste. So it will automatically affect the data transfer speed. That means small amount of data is transferred with slow I/O devices. Next is interrupt controlled data transfer. It is similar to interrupt driven I/O. Means in this the data transfer is controlled through interrupts. That means in this CPU just issue command for I/O and do its work. When the data is ready to be transferred, then I/O devices or interfacing devices interrupts the CPU. That means the waiting time is reduced. In this time, CPU can do its another work. So this is the flowchart for interrupt controlled data transfer. In this method, CPU issues a command to the module and then do its own work. Okay, then that means CPU is free after sending signals to the interfacing unit, and I/O interfacing then proceeds to read data from the peripheral devices connected to it. And after the data is ready, then interface unit will interrupt the CPU, and then CPU save its own program contents into the memory or stack and then service this interrupt, this I/O devices. And after servicing this interrupt, CPU will restore its address or data from the memory and then continue its execution. So in this flowchart, you can see I/O instruction. CPU interprets and sends I/O commands to interface unit. Some part from the starting is same as in program controlled. Then interface unit will assemble word in IBR, and then we have to check IBR is full or not. If full, then CPU will send this data to memory. But in this, interface sends an interrupt signal to CPU, and then CPU completes current program instruction, and CPU stores the program in the main memory. Means at starting, CPU just send this command to I/O unit. After that, interfacing unit will handle all the things. When there is a requirement of CPU, then they will call CPU. Then they will send signals to CPU, interrupt CPU. Interfacing unit assembles the word in IBR and check if IBR is full or not. If not, then it will continue to assemble the words in IBR, instruction buffer register. But if IBR is full, then interfacing unit will send signals to CPU. Means this is an interrupt from interfacing devices to CPU. Then CPU will complete its current instruction execution and store that data, store that address in the memory, and completes this data transferred into memory, IBR data into memory. And after its execution, after transferring of data to memory, then CPU will restore its address from the memory or program counter wherever it is stored, and then continue its program execution. So this is the interrupt controlled data transfer. Means CPU is just have to send the signals to the interfacing unit and then free to do its own work. If there is a requirement of CPU, then only interface unit will interrupt CPU so that the CPU can transfer data from registers to the memory. Otherwise, CPU will free to do its own work, to do its program, or to do execution of these instructions, whatever CPU is doing. So these are the techniques for data transfer: interrupt control and program controlled.